Hi, Danny Pigeon here, Marketing Assistant at Saratoga Horseworks. Whether designing a new product or revamping an old one, testing is an important part of the production process. At our facility, we have the capabilities to run a number of different tests for clients unable to do so themselves. Today we're going to go back into the testing lab and talk with President Michael Libertucci. Hi Mike, there's definitely a lot of cool gadgets around here. What kind of tests can we run with them?
Well, Danny, we can run quite a few different tests here. We can do seam strength tests, tensile tests, we can do various types of buoyancy tests, short and long-term air retention tests. We can do pneumatic as well as hydrostatic pressure tests of flexible vessels, and we can even take those to destruction if we need to. One customer who came to us recently that received a batch of overpressure valves that they thought weren't functioning the way their earlier batches had. So they asked us if we could test them to see what their opening and closing pressures were. So they sent us up one of the new ones, an old one, and one they'd been using for a while. So we made a test bladder, and in that bladder we had 3 fittings in it, one for an air fill, one for the overpressure valve, and one for a pressure gauge. And what we could do is we could fill it up to the point where the overpressure valve actuated and measure the actual pressure that it opened at, in both at its minimum and maximum settings. As it turned out, the overpressure valves were just fine. They felt a little different, but they worked just like they were supposed to.
Very cool. So what tests are you running here?
Well, I'm running 2 tests today. We're doing seam strength tests on welded seams as well as a medium duration air retention buoyancy test. What we're doing with the seam strength test is we're cutting samples out of a welded air cell that are 1 inch wide, and they go in the clamps of the test device. And when the ADMET 7600 test tower runs the test, the jaws are moving apart at a rate of 12 inches a minute. And they'll keep pulling on the sample until it fails. And the whole time, the load cell is measuring the amount of force it takes for the sample that it's taking, and then it records it at the exact instant that the sample fails. And in this case, this sample broke at 89.55 pounds, which is well in excess of the 46 pounds the Underwriters Laboratory sets for personal flotation devices. Now we can either manually record this device, or the test tower will upload it to a laptop, in which case we can print the reports off. Now, UL gives us specific reports we have to fill in, so unfortunately we have to do that manually, but the reports themselves calculate all the values after the fact. Now, the medium air retention buoyancy test is a 6-hour-long test, which we started earlier today. What we do is we weigh our basket in the buoyancy tank. We then put in an air cell under the basket, and we let the pressure and the temperature of the gas inside the air cell stabilize with the water temperature in the tank. And we actually have to record the barometric pressure at that time too, because 6 hours later it could be different. So then at the end of the test, which we're just coming up to now, we'll record the value on the scale, and the starting, the stabilized, and the final buoyancy of the device cannot have altered more than 5%. So then what we'll do is we take the device out, and it has to still be a functional air cell at that point. We haven't found any leaks in it. And in this case, this one did indeed pass its test. The value on the scale was within 5% of its stabilized buoyancy.
It's pretty cool, all the tests we can run right under our own roof.
It is. You know, I don't wear a lab coat very often, but this lab has been a great resource for our customers.